This video deals with solving exponential equations with logs. Okay, we've looked at solving exponentials when we have a common base, but normally when you solve an exponential, the inverse of an exponential is a logarithm. So this equation right here says 19 to the m minus 5 power minus 6 is equal to 59. Now, first thing I need to do is to get this exponential by itself. And we have minus 6 here, so this looks like it belongs with this over here, which it does. So I'm going to, get the exponential on one side by itself and the regular number here on the other side with what it belongs to, its cousin, so to speak. All right, so that's minus 6. To get to the other side, I would do the opposite, add 6. So when I do this, that gives me 19 m minus 5 power, okay, and equals 65. All right, now, if you just look at this, and you think to yourself, okay, I got to raise 19 to a power and get 65. Well, 19 to the first power is 19. But 19 to the second power is, that's almost 400. So it's got to be 1 point something. Okay, so I've got an idea of what it should look like. It should be where this exponent's 1 point something. So whatever minus 5 will give me 1 point something. So it should be like 6 point, whatever, 6.5, 6.4. But anyway, that just gives me an idea of what the answer should look like. Now, this exponential right here equals 65. Now, of course, there's no common base. So what I can do is just take the natural log. Natural log is ln, and the log to the base 10 is log. So I'm going to take the natural log. And as long as I do it to both sides, it really doesn't matter. As long as I do everything that I do it to everything in the equation, I'm all right. So I'm going to say ln of 19 to the m minus 5 equals ln to the 65. Okay, so I just took the log of both sides. And as long as I do it to everything, I can do that. All right, now, but what that does is anytime we take a logarithm, the rule is that the exponents come out to the front and become a multiplier. So I end up with m minus 5 out front times ln to the 19, or the natural log of 19, equals the natural log of 65. Now, just like with any equation, I want to solve for my variable. Okay, my variable is m, so I need to isolate it. So I'm going to move this to the other side by dividing both sides by the natural log of 19. So if I divide this, I get natural log of 19. And of course, when I divide this by the natural log of 19, which is really this whole thing here, I end up with that canceling out, and I end up with m minus 5 equals ln to the natural log of 65 divided by the natural log of 19. Now, what does that mean? All right, well, this right here, these can be put in your calculator, but I'm not ready to do that quite yet. I still want to isolate my variable. So what I'm going to do is I'm going to add 5 to both sides. If I come over here and I add 5 to this, then I end up with this right here. I end up with m by itself, and I end up with the natural log of 65 divided by the natural log of 19 minus 5, or plus 5 rather. All right, now if they ask me for an exact answer, I would be finished. That would be my exact answer. Because when you take the natural log of something, the calculator is going to round it off. It'll be a decimal. It's going to be rounded off. So if they ask for an exact answer, this is the way to leave it. But that's not the way we're going to leave it. We're going to actually put it in our calculator and finish it on out. So I have m is equal to the natural log of 65 divided by the natural log of 19 plus 5. So if I put that in my calculator, it's just as simple as putting in natural log. What I do is I mash the LN key on my calculator, and it gives me a parentheses, and I put in 65 and close the parentheses and say divided by ln of 19. Close that parentheses or mash enter. And I end up with, now we're going to round this off, I end up with 1.4177 plus 5. All right, and then all I do is I add those two together. And like I said, this is rounded off. And so you got to be careful with your rounding that you just, you don't want to round more than once. So say this to the end instead of doing that, earlier in the problem, save it to the end. All right, and then what happens is I end up with, if I add these two numbers together, I end up with 6.4177. And that is my answer. And that makes sense. If I look back at the original problem, I see in the original problem that I needed to have an answer of 1.4 or 1.5, and it was m minus 5, so this minus 5 gives me 1.4. So my estimation was correct. So this is the answer. M equals 6.4177. This is an approximation, which means this really should be like this, whereas this answer here is an exact answer, although it doesn't look real nice. I know that most of you wouldn't like the way this looks, but this is an exact answer here. And I will always, the teacher will always tell you what they want, either an exact answer or the approximation, which just means that it's rounded off when you put it in the calculator. So that's how you do one with logarithms. That's how you do an exponential using the inverse logs to solve. Good luck.